Welcome back. In this video, we're starting to look at how we do multiplication of fractions. The focus in this video is on some basics and some kind of introductory ideas that will help us develop how it is that you actually do multiplication of fractions. The first thing that we need to look at is how you do how you find the area of a rectangle. So that's where we're starting. So you may already know the formula for finding the area of a rectangle, but just in case you don't, I want to make sure that you do going forward. So to do that, we need to talk about just how measurement is done for a little bit. And so we want to think about how it works when you measure a length. If you wanted to know the length of, I don't know, a piece of wood in your backyard or the length of this blue line on the screen, how you would do it would be by laying like a ruler up against the object, either the piece of wood or the blue line, and compare how many, in this case, let's say inches, it takes to equal whatever that length is. And so you'd say, okay, well, there's 1, 2, 3, 4. So it's 4 inches long. The answer here doesn't matter. What matters is you are using repetitions of some unit that you know to report some length. You have something whose length you do know, like little pieces of inch off of a ruler or feet from a tape measure or whatever, and you're using repetitions of those units to find the length or report the length of whatever object it is. That's how length works. To find an area is an amount of surface of a plane that is taken up by something, like this 3-inch by 4-inch rectangle you see on the screen now. The standard unit for area is a square whose lengths are 1 unit on each side. So you can see this 1-inch by 1-inch square. We would count repetitions, again, of this known unit, a square inch, and see how many of them it takes to equal the area inside of this rectangle. So to count those up, as you can see from the drawing, well, there's 4 of those squares in each row, and then there are 3 rows, and so 4 times 3, as you know, is 12, of course. So that suggests a formula for how you find the area of a rectangle. We'll use the letter A to stand for area. In fact, let me just go ahead and write it down. The area is equal to the product of the length and the width of a rectangle. And you can think of why that is that we're counting up a certain number of squares. The width tells you how many squares there are in one row, and then the length tells you how many rows there are. And we use multiplication because it enables us to count up all these squares so that we're not saying 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's the way that works. The area of a rectangle is the product of its length and its width. So just as another quick example, let's say that we have a rectangle that is 11 inches by 7 inches. I don't think you want to see me draw in like 11 squares 7 times, right? So definitely don't want to see that. But if I did, there'd be 11 squares in each row and 7 rows. So we would have 11 times 7, or 77 of those square inches. And that IN with a little 2 on top, that's the symbol for the square inch unit. So our final answer there would be 77 square inches. It turns out that the formula for the area of a parallelogram is the same. A parallelogram is a shape that looks kind of like a rectangle. It has 4 sides. It has 2 pairs of parallel sides, like this one. And opposite sides are equal in length. There's another handful of other properties that this shape has. A kind of nice, easy, intuitive way of thinking of what a parallelogram looks like is to think about, what if you had a rectangle and you put hinges in the corners and leaned it over a little bit, perhaps? That would make a parallelogram. So the key features that you need to know for a parallelogram are a base length, shown here as the 7, and the height. The height is the distance between the 2 parallel bases, which in this picture is going to be the 4. Be careful, it's not the 5. The 5 is something else called a slant height. You want the 4 for this. This would be the distance between the two parallel sides that I'm identifying as the bases. And so how to think about the area for this parallelogram, we're going to do kind of a thought experiment for this. You see this little triangular piece that is sticking out here on the left? I want you to visualize taking that, and we're going to get a pair of scissors and cut it off, and we're going to move it to over here. We'll glue it on right there. Okay, so we've taken off that little rectangle that, or triangle, sorry, that was sticking out, and we've kind of glued it onto the right side. So if you do that, what you get is this rectangle shown here in yellow. And this rectangle has a width of 7 and a height of 4. So, and is a rectangle. And so following our discussion about the rectangle earlier, its area is going to be 4 times 7, or 28. And I didn't give a unit, so we'll leave it off. So the point here is that for a parallelogram, the area is also length times width, just as it was for the rectangle. Of course, being careful to note what the width or what the length is actually the distance between those two parallel sides, not the 5 in this picture. Okay, so parallelograms and rectangles have almost the same, will have the same formula for the area. All right, so we want to look at triangles next. So I want to think about triangles. There's just a handful of different ones here. We'll use those in a minute. So the key features that you need to know for a triangle are, we're going to use the letter B to stand for the base of the rectangle, and then triangle, and the letter H to stand for the height of the triangle. The key kind of observation that we need to make on a triangle is that if we so chose, we could double it up into a rectangle that has height H and base length B. And so that whole rectangle would have area B times H, base times height. That would be the area of the whole rectangle. We, of course, only want half that because we're trying to find the triangle part. So it's going to be 1/2 of that amount, base times height. Here we haven't really practiced it, multiplication involving fractions. That's why we're here. But now we have the formula at hand anyway. So we want to take half of something, and the amount that we have that we're taking 1/2 of is that base times height value. Okay, so there we've seen that for a right triangle. We want to illustrate how that works for some triangles that aren't right triangles. So I'm going to start with this one up here that is 1. So what I'm going to do, this thing is not a right triangle, but if I kind of proceed in the same way as I did here, we're going to see that this ends up looking like a parallelogram. So I've made just a little copy of the black triangle kind of flipped across that slanted line here, and that makes overall for a parallelogram. This parallelogram, we can figure out its area as we did before. Its area is going to be 1, 2, 3, 4 across, and 1, 2, 3, 4 in height. Okay, so this is 4 times 4, or 16. That would be the area of the whole parallelogram. Of course, we want to just half that. So half of 16 is going to be 8. So then the whole area of this triangle in 1 is going to be 8. Okay, so now let's try number 5. Looks good. The others are going to kind of cross over. So let's try number 5. So for this one, we'll have 1, 2, 3. Okay, so here in number 5, this doubles up to be a parallelogram that has width 3 and height 1, 2, 3. So half of 3 times 3, 3 times 3 is 9. And then we're going to have half of 3. Sorry, half of 9. All right, half of 9, we're going to hold off on what the answer to that is yet, because we haven't really looked at multiplication of fractions. If you, depending on your background, you can look at that and you can say, well, it's 4.5 if you want to think about decimals, or 4 1/2 if you're ready for that yet. Or, yeah, let's leave it like that for now. So the key thing here, and I'll leave it to you to try these others, is that the formula for the area of a triangle is going to be 1/2 of the base times the height for the triangle. All right, so those are a couple of area formulas that we will need going forward. The other thing, or another thing that we're going to need, is a couple of properties involving multiplication. So less pictures here, just numbers. So 2 multiplication properties. The first one is that multiplication is commutative. And so what that means, well, first of all, let me back up a second. As a reminder, what a property is in math is not like a house you own or something like that. A property is more like a rule or a behavior that numbers go by, or an operation goes by. And here, when we say a multiplication property, we're talking about how does multiplication work? What is its behavior? Okay, so the commutative property says this, that if you multiply 2 numbers together, it doesn't matter which one comes first. So 3 times 5 is 15, and 5 times 3 is also 15. Okay, 4 times 11 is 44, and 11 times 4 is 44. Thinking back to the rectangles that we just did, I know I said no pictures, I lied, sorry. If you have a rectangle with a height of 8 and a width of 10, its area is going to be 8 by 10 or 80. If we were to take and give this picture a quarter turn so that it is now 10 by 8, all right, does that rectangle change area if you rotate it by a quarter turn? No, it's still going to be 10 by 8, which is still 80. That's the commutative property. It says it doesn't matter what order you multiplied 2 numbers in, you're going to get the same answer. 168 times negative 372. I'm not sure what that is. Okay, but whatever it is, it's the same as negative 372 times 168. Okay, a way to remember the name of it is if you commute to school or commute to work, that means you drive there and drive back again. You go both directions. Okay, that's how multiplication works. You can go both directions and get the same answer. Okay, another property that we'll need is the associative property for multiplication, and that one goes like this. If you want to calculate 2 times 3 times 5, here there's 2 operations to do. You can calculate this as 2 times 3 first, and then multiply that by 5. 2 times 3 is 6, times 5 is 30. Or you can do the 3 times 5 first. 3 times 5 is 15, and 2 times 15 is going to be 30. Okay. If you have just an expression or calculation to do and it's just multiplications like this, it doesn't matter which multiplication you do first. Okay, so as another example, if we wanted to calculate 5 times 3 times 4, so here you can put parentheses. Let me take the parentheses off for a second. If you have 5 times 3 times 4, you can kind of associate or group the 3 times 4 together first and say, well, this is the same as 5 times 12, which is 60. Or you can make parentheses around the 5 and the 3 and multiply those two together. 5 times 3 is 15. 15 times 4 is 60. You're going to get the same answer. So the point, big idea here is that you can, if you have an expression or calculation to do that just has multiplication, it doesn't matter which you do first. Okay, and that's the associative property. We're going to need these two properties going forward when we work on multiplication of fractions, which is coming up. That takes us though to the end of this video. In the meantime, let me know if you have any questions and have a great day.